So welcome to the study of linear algebra. Here, I would like to introduce what is linear algebra and what it means, and introduce you to the course, and also introduce you to learning math in university settings. So first of all, I would like to cover what is linear algebra, like what it is, right? The word linear algebra doesn't tell you anything else, except those two words. So I would like to describe it a bit. So second of all, why do we need to learn this subject, right? Why? So after you go into this course, you will have a bunch of solving equations and a lot of stuff. But in general, why? So that's a pressing problem, right? And finally, I would like to address how, right? How we can learn this subject, right? Okay. So to start with, what is a linear algebra? So the linear algebra is basically to me, okay, so it's probably different for everyone, but for me it's a study of line and planes. So say if you have say a 2x plus 3y equals a 13, and you have 2x minus 3y equals a 3. If you're solving this linear equation, you can solve in your knowledge, right? You can solve it by substitution, by elimination. But essentially what it means when you write down these kind of equations. So essentially what you are doing is you are having a diagram. Say if you're having two straight lines, probably they are not related to each other, since I haven't calculated, but if you have two straight lines which doesn't parallel to each other, then they will have a unique intersection, you can see, right? So that's the solution that we want to see. Okay, so study of linear algebra is basically you are having a bunch of lines or planes, or you are working with higher dimensions. Okay, so in that case you have a hyperplane. Okay, so if you are having those objects, what are the intersections, or what are the solutions to equations? So that those are our object of studies in this course. And we'll introduce a bunch of techniques, but it's very important to remember what is our goal, right? What is our goal to understand? So the goal is to understand the things about lines. So it's really something about visualization. You really want to see what you're doing instead of working with numbers, remembering algorithms. Those are not for human brains. Okay, if you want to do algorithms, go to do coding course, and then you just code in your computer, and that's all. Okay, you don't do the algorithms in your brain. Okay, those algorithms aren't the most important stuff to take away from this course. The visualization, the concepts are. Okay, so after this, let me tell you why we need to learn this a linear algebra, right? Lines, we all know how to draw lines, and we all know what planes look like, right? If you have a piece of paper, if you hold it in front of you, then that's a plane, right? So why? So the first thing is a very important is for computation. Say if you have a Rubik cube, okay, so Rubik cube is very complicated. I can't do a Rubik cube probably properly. So uh if you want to have your computer solve the Rubik's cube, how do you do it? Okay, so it's usually you can hard code it, right? You can hard code all the things, but one way to do it is by linear algebra. So you can try to turn the actions, say the right, left, a 90 degrees, a 180 degrees, something like this. So these are all actions onto that Rubik cube. And you turn it into a bunch of numbers. So essentially what it should look like is it's probably something like this. Okay, sorry, probably something like this. Of course, in the Rubik's cube is much more complicated. Okay, but you can turn it into a bunch of numbers, and those numbers you can calculate in your computer just using addition and multiplication. So you're turning the Rubik cube Okay, so like this is very complicated, right? I mean, like there are a lot of things, which like they stacks, right? I mean, like rise 90 degrees. If you do it for 4 times, it becomes like the identity, right? You want to have your computer to understand this logic. So how? So you can use like these kind of numbers to encode it and to turn the like a computation to having only addition and multiplication. I know that like many will tell me like okay, addition and multiplication are very expensive in like a computer. I know, but like at least it's a way. At least it's a way to turn like a real life like actions to like something which like computer can handle very easily. So it's a unified way to understand things. So it's usually called like the representation theory. So you can see like I use like these two words. Those have like actual meanings in math, but like we are not going to discuss like even in this course. So another thing is like to like compress the information. So say like if you have like these kind of like data points, so you have a lot of data point like this. So how can you compress all the information? You can see like we can somehow see that there is like a, let me use another color. Okay, so we can see like there is like a actually like a two like a direction, right? So two direction of this like a data point, and like these two direction really defines how the data point looks like. Okay, so like for example, um how to save an image in your computer. So image are very big. If you like think carefully, so say like even like a 1024 times like I don't know like 768. I've forgotten the real figures. Okay, so if you have that like image, so each pixel have like the red, blue, and like green, right? So you are having like 1024 times 768 times 3, and it's very big and it's usually called like BMP, right? So like to save it in your like phone will take ages, right? I mean, so what is a better way to like save the image in your phone, or like to make it like a better, right? I mean, like to like save some spaces. So usually what it what it does is like to like so the word is to extract main features from the image. So like there are some main features of the image. So for example, if I like give you like say like a flag of say I'm not like having like any like a particular like a say like pick a particular country. Okay, so like say like a country flag of like Japan, or like any like a sort of like a simple geometric like figure that you can like imagine in your brain. So like you can see the feature are very simple. You can see like they're like very simple feature. Like you can see like it is like white here, white, and this red here, right? I mean, like there are only like two things to remember in your computer, and it doesn't need to like go through like this kind of like huge object to remember all the like a figure, right? So the compression of like information is to find the main features. But what exactly main features are, right? I mean, like you can't look at each figure and then you like figure out what are the main features and things, right? So there is like a technique called like diagonalization, which actually like in linear algebra, which is all about like extracting main features. And that's the technique that you can learn after learning in linear algebra. Okay, so that's like one of the importance of like a linear algebra. I mean, like there are some subtlety, right? For example, like not every like matrices are like diagonalizable, or like there's some sort of like ambiguity there. But like put it aside, okay? Like generically, every like matrix is like diagonalizable, and like you can extract like information from this, and like that's what I want to like tell you in the first course. Okay, I mean, not going into like the technical like details right now. Okay, and like another like point of it is to like have a simplified version of difficult concepts. So I'm not sure like which background are you in. You can from like you can be from like a math department. You can from like statistics. You can from economics. You can from like many different like faculties. I don't know. But like if you are learning math, math are very difficult. Like let's just like admit it. Math is difficult, right? I mean, like for me, I can't learn like math very well. To say so like math are difficult. Why? Because the abstract like the concepts are like abstract, right? I mean, if you ask like hundreds of like people on the street why math are difficult, they would just tell you like math are abstract, right? I mean, they are boring and abstract. The abstract is like it's very difficult to understand the concepts. And how to understand concepts well? So our brain is not built for like a logical arguments. Okay, like we don't like accept like a logical arguments very well in our brain. What our brain remembers are examples. So, like in math, especially like if you are learning in the university level, examples are the key. Examples are the key to understand everything. You need to have examples to understand the theorems and the concepts. And how to gain examples? I mean, like you can try to see like the modern papers to gain examples, right? But they are very difficult to understand. So linear algebra is like kind of a sandbox or kind of like a simplified version of like the many difficult theories or like concepts, which you can learn in like 300 or 400 level. So let me give you like some like a sort of example. So I said about like a linear algebra is like a study of like lines and planes, right? So for example, if you have a plane and you have a line where you want to have like every single point maps to like the nearest points on the line, okay? So you find the nearest point of the line where it maps to. It's called a projection, okay? So I mean, like the projection itself is very easy, right? I mean, like even in real life, like if you are standing on the ground and then you have like you're like a person, you are standing here, there is a sun really like far away here, and I don't know why the sun is like in light blue, okay? So when you have a sun, then your like a head is like a projecting here because of the like a thing, right? So you have like every point a projection, every point has a projection like this, okay? So you know projection very well, okay? So but the projection here can be turned into the quotient of spaces, which are like a very difficult concept. Like it's just not easy. Like when you have like say like quotients of groups, like quotients of groups or like rings, they're very difficult. And not very difficult, but like they are like abstract, right? I mean, how you can understand those concepts are by projections. You look at the examples that you know. You know by your heart, and then you understand the thing. Okay? So like it's the same as like there's like something it's called kernel or like other sort of like a concept words which are like difficult, right? I mean like when you first learn in this course they are difficult. But after you learn in this course, and when you see it in like a more abstract like settings, they become easier. And why we need to introduce everything with linear algebra, right? I mean like I can introduce you with like other settings. Like I love groups, I love rings, but linear algebra is very good since it has many axioms. It has addition, it has multiplication, and it looks similar to what you have. For example, you know like x plus you say like x plus y equals 5. Like those things are really familiar to you, right? These things are like the basis of like how our mind grow, and that's why like we are introducing it in this way. So another thing is like called rank nullity theorem, which is like a more abstract, right? I mean, let me use like a simple example to like tell you. Okay, so the thing we had is like the plane, right? And then it projects to a line, right? Okay, so let's look at like what they mean. Okay, plane is two-dimensional, right? I mean, if you like know like the word dimension without even knowing what it means, so plane is two-dimension, and line is one dimension. Okay, because like you can only like walk in one dimension here, but you can walk in two dimensions here. Okay, so let's look at how the things projects. So you can look at like all these lines, like you have a like a whole line here, which maps to the same points, right? So all these points are mapping to the same point on the line. Okay. And now like what is this like the dimension of this? This is also one dimension, right? Let's like just so you can see like the whole one dimension thing is crushed into like the line, into one point of the line. Okay, so you can see like there are three like numbers here. So you have 1 and 2, and we all know that 1 plus 1 equals 2, right? And what I mean 1 plus 1 equals 2 is like this one plus this one equals this 2. Okay, and this exactly is like rank number theorem. And you will see exactly how it looks, right? I mean, like I can even draw you how it looks, but it leads to like a more difficult theorem, which is called like a first isomorphism theorem, in like a group theory or in ring theory or in modular theory or in many theories in math, and that's of the fundamental like importance, and that's why like we care about like a learning of all these things. And like finally, like to like linear algebra, like let's go back to basics. Why we need to learn it, right? I mean, to understand linear equation is definitely one of them. And you can tell me, oh, I know how to solve equations, right? I mean, I already know how to solve equations. I learned it from high school, I learned it from middle school, I learned it from even elementary school, right? I mean, I learned how to solve like 2x plus 5 equals 9 in my grade 4 or grade 5 exams. Or if you're a genius, you probably learn it in like grade 1 or grade 2. So why we're learning it here? It tells us about the general behavior of linear equations. So, for example, if I have like three variables, like this, and then I have two equations. Okay? So, what I can tell from this kind of like a equation. So I can tell you a theorem like it's just like so like I'm telling you something like in the course, which is very interesting, I find at least. And there's like these equation sets never have like a unique one unique solution. And what I mean is like no matter how you change, you can change many. You can like I am giving you this condition like three variables, two equations, linear equations. Okay, linear equations. I need to be linear. So if you can like tell me any kind of like equations you like with any kind of variables you like, and I can tell you as soon as you are having three variables and two equations, you will never have a equation set that have only one solution, one and only one solution. You can have no solution, you can have infinitely many solutions, but you can't have one solution. That's what I can tell you. Okay, and these are like just because you know like linear algebra, you can tell everyone like with like 100% of confidence in your hearts that is true. And that's like one of the like importance of learning linear algebra, right? I mean, we all love to have like a quick and easy like a outcome from like courses, and this is one of them, right? And also like it leads to like even like harder like things. For example, it leads to like you to like a study of like dynamical systems. So what is the dynamical systems? For example, like a change of populations, say like a prey and like the predators. Okay, or like economic models. Okay, those are like can be modeled by like dynamical systems. So By the way, like there is a course on dynamical systems which are taught like inside McGill, so you can like even take it. Okay. So let me give you like two examples. So these are just like garbage. Okay, I mean like those are really good examples, but like I mean like it doesn't read anything familiar to you right now. Okay, so just look at these figures. Okay, so we are having like these kind of like complicated equations. They are not very easy to understand, but like what linear algebra can tell you is like this. So at this point, just look at like what is around here. You can look at there is like two principal axes like this, right? There's like a horizontal principal axis and vertical principal axis, and you can analyze it just by looking at this equation by linear algebra. And similar here, you have like two principal like axes, and it's a rotation around this. You can see there's a rotation. I'm not sure about like the direction. I forgot about the direction, but like so now here you have like also a principal axis where like the things are coming here and coming probably here. I forgot like about the directions. Okay, and here you can see the principal axes are here, and the things are like probably going here or like going like in another way. Okay, but like you can see that we can analyze where the like principal axes are and what are the behaviors of these like actions just by analyzing the equations. And how can we analyze the equation? It all goes back to linear algebra. And that's why I need to like repeatedly emphasize how important linear algebra is, since like it leads to many different theories in mathematics. There are other like applications, say like functional analysis, and like it's really like there are many of them, but like I'm just going to like give you some which I find like interesting, and I find like there can be figures that I can show you right now to catch your attention, right? I mean, or else you won't even listen to me. Okay, so finally, how to learn. Okay, so here I'm going to like address the most important part of this course. This course is really not about learning the techniques, learning the algorithms, or learning how to do 1 plus 1 equals 2. This is never the objective of this course. The objective of this course is to understand the concepts behind, to visualize things, to understand what is the learning philosophy of, like, what is the philosophy of learning mathematics, how to learn, or like how to even learn in general, like not even math, right? So to start with, like learning mathematics are difficult. I mean, like it's difficult, right? I mean, so we need to learn like by practices. So we need to practice. Like you can't say oh because I'm learning mathematics so I can like just understand without like exercises. It's not possible. Okay, you need to do exercises. You can find practices like on like textbooks. You can find it on web work. You can find it from tutorial questions. If you are not if you don't understand any of the questions, you can like ask in office hours, or you just ask your like peers. Find your group of peers that you like to work with, right? I mean, you are in university. What is the benefit of being in university? But like you can't do it. What you can do in university, but what you can't do when you are learning on YouTube or on anything by yourself, is your peers. Look around you. Look around the all the like, intelligence like people around you. Those are your assets. Please make use of them. Like please befriend them and to work with them, to understand math with them, and to have fun with them. Those like they are going to be your friends for the rest of your university life, and you will learn math, you will learn how to do different things. You can learn from each other. Like they are very valuable assets in your university life. Okay, and also like another part is to really visualize. So in this course, like after this, after this session, after this like a tutorial 0, there will, I mean, I will be focusing only on like a computational part, like unfortunately, since like a tutorial is what it made for, right? I mean, lectures are telling you about like concepts, but tutorials are making you like torturing you to do like a harsh calculations and like difficult calculations. I mean, what you can do in computers, what I hate to do, I will make you do. Okay. But what is important is to like really visualize what you are doing. For example, what is x plus y equals 0? You can read it as like 1 times x plus 1 times y equals 0, right? I mean, like you can treat it as numbers. But what it really means is really a line like this, okay? And what is x plus y equals 1? It's another line like this. And you can see, since they are parallel to each other, they have no intersection. And that's why these equation sets have no solution. And you can see it by the figure, right? It's very obvious. And that's how you learn math. Like, you're not learning math because like you are learning math by theorems, you memorize the theorems, like you memorize your poems or memorizing history. It's not the same. Math is about example and understanding. You need to practice, but as like also you need to like make the like examples abstract, make them into like your heart, learn them by your heart. Like you need to like see the like they are parallel, and that's why there are no solutions. You will learn like soon about like RREF. You will learn about like many like calculation techniques, but it's of the utmost importance to visualize all the things so that you can see why there are no solutions, why there are infinitely many solutions. I'll give you another example, like this. So this just looks like 3 variables and 1 equation, right? I mean, but like you should like look at like you should like visualize it as a plane, right? It's just a plane. And say like if I'm having 2 planes, okay? What are the possible intersection of them? The intersection must be a line or nothing, right? If you have 2 parallel planes like this, the intersection are none, are null. But if you are like 2 non-parallel planes, you are always having a line, right? You won't have an intersection of points. It's like 2 planes can never intersect at a point, right? I mean, this is very easy, right? You can even imagine your mind. But let's go back. You remember, like I told you about like the equation. Let me find this one. Okay. I told you about like the 3 variable and 2 linear equations, and I never told you why like these kind of like equations have no like can never have unique solution. But that's the reason. I've told you a reason here. If you have like 2 equations which like are corresponding to 2 planes in like a 3-dimensional space, which is like have 3 variables, you can never have a unique solution. You can never have an intersection of only 1 point, which you can see. So visualization really turns the difficult theorems into like easy to understand things, which you can remember in your mind. And you can remember even the generalization of them. And that's the like the principle of learning in math, I would say, like at least like a undergraduate university level, okay? But yeah, that's like how I would like to introduce linear algebra, and I hope that you have a nice and like happy journey in learning linear algebra. Remember, never learn the algorithm without understanding concepts. Concepts are the most important things in like learning math. I mean, if you are not prepared to be like replaced by a computer, you shouldn't learn like just by algorithms. So thank you very much.